Hi everyone, welcome to the data structure algorithm session 2.2. This is regarding doubly linked list. Last one was on the singly linked list. So I will hand over to Jaymeet to proceed on the uh, DSA session 2 of 2 doubly linked list. Thanks. Take over, Jaymeet.
Thank you for the introduction. So, hello everyone. This is a continuation of the TSA session that we did earlier. Earlier, we discussed about the single linked list. Now, we will be discussing about the doubly linked list, its header files, and its C program. Now, most of the contents of the doubly linked list program will be similar. So I'll be talking only about the differences that there are there between the single linked list and the doubly linked list header files and the .c file. So first, let's just discuss a bit about doubly linked list and what it is. So doubly linked list in which elements are linked by 2 pointers instead of 1. The structure allows the list to be traversed both in forward and backward direction. As you remember, in single linked list, we only traverse from head to tail direction, and we used only one pointer, which is the next pointer. In doubly linked list, we have more flexibility compared to single linked list. Whenever we feel that single linked list implementation of is limiting us in any manner, let's say it's moving in one direction is any kind of a drawback to us for its implementation, then we can use doubly linked list in that case for easy traversal of the list, and we can uh, traverse to whichever direction we can choose our direction, whichever is optimal for our use. So you can see the implement diagram of a doubly linked list and how it's done. So you can see the previous pointer pointing towards the previous element, and the data and the elements next pointer pointing to the next element, the one that is after it. So now let's get to the code of the doubly linked list. So as you can see, these are the code that are anyway similar to the one that we saw in single linked list. The difference being here is that we have a previous pointer for the uh, uh, list element, and other than that, most of the contents are same. The way we define the structure of the list in the single linked is the same as this one. Then we have a different other macros. We have now the additional macros are the one that we had in single linked list was a dlist list insert next. Now we have list insert previous to. Then we have dlist remove, not remove next or remove previous. We can now remove the very element that we have selected. If we insert, we will be inserting in previous and next manner, but we can remove by selecting the very element we want it to be removed. Other macros are self-explanatory in a way that they have been named. Uh, it, the DList is head, just returns 1 if it's head, and same for tail if it returns 1 if head, and 0 if not, and so on. So these are the contents of the header file. Now let's get to the program. Okay. So first, these are the header files that we want. List.h is the header file that we have discussed here, and we have included it over here. Then we start by initialization of the list and its arguments these are the initial values. And these are the this is for a delay destroy for removing each and every element, a while loop to loop through each and every element as far as there are elements in the list. Then we have delist insert, and this condition to basically check whether we are not removing an element from the null list or an empty list. Then this is the insertion of the element using malloc. This is basically the same way that we did it in single linked list. So this is the insertion of insertion happening in the for the new element that we are trying. So new elements data is being stored in this data pointer. Then it starts with this. If the element or if the list is empty, then this is the way it will implement. So if the list is empty, then it's going to be the head element that will be saving the new element. And because it is the only element, the tail pointer has to be has to be be saving the new element as well. So head and tail both will be the same element, and the previous and the next pointer being equal to null. If the insertion is not uh, in an empty list, then this is the block that will be executed. So first these are the arrow operations for starting the new elements. Next pointer will be pointing towards the previous elements, what the previous elements next pointer was pointing to. Then new elements previous pointer will be pointing to the element that it was that it is previous to. So this is the element. Then if the element is equals to null, which basically means that if it's a tail, then the tail being equal to the element. If the insertion is not on the tail, then these are the things that it will happen. These are the code that will be executed. And the pointers will be updated in this manner. So this for start, this is basically the element of the next pointer is accessing the previous pointer and giving it the value of new element, and then the element's next pointer will be pointing to the new element. Now, because the insertion is successful, we will be incrementing the value of size of the list. Next is insert previous. Similar to the insert next, the previous one will be done by these operations. If the list is empty, and by these operations if the list is not empty. Most of the explanation is similar to the one that carried further, carried that were carried before. And after insertion, we will increment the size of the list. Now, for removal, we'll be removing the very element that we have selected, not next or previous, as was in the single linked list case. So first, we'll be checking the condition for we are not emptying an element from the empty list already. So if it is done, then it will give us the return value of -1. If it's not the case, then it will move further and then implement these codes. Then so removal from the element of the list. These are the lines of code. If it's at the head, these are the code that will be executed. If it's anything other than head, then this is the code that will be implemented. And after After the implementation, the element that was selected will be freed using the free function and passing the element as the argument, and the size of it will be decremented. So these are the operations that are for the doubly linked list. So this was the whole presentation for the explanation of the doubly linked list, its header file, its .c file. So thanks a lot, and next will be for the circular list.
Can you stop yourself?